Hello, students. Welcome once again to another section. Now we have a question on line of best fit. So we have the question says we should fit a straight line to 100 meters data from 1991 to 2005. So now we have s values and also the y values. S values represent the years, the y value also represent the data. Now the first question is, what would you estimate was the fastest time rain in 1968 from the feet, and if the world record is broken in 2017, what time would you estimate that it would be? So now in this question we are going to use the line of best fit, right? And the line of best fit, we know y here is given by a plus bx, right? Now generally is given by two equations, right? So the first equation is na then plus b here, which is a constant, then multiplied by the summation of all the s values being equal to the summation of all the y values. And the second one here is just a, then the summation of all the s values here, then plus b here, the summation of all the y values here, sorry, s values, but it is squared, s values it is squared, then being equal to the summation of all the s values and also the y values, right? Okay, so these equations, there are two equations. When we get the various values for the s, the y, and all that, we just put them together to find a and b, then we substitute it into this equation here. Then from here we can calculate for the values of a and b from the question. Okay, so you realize that from the equation given over here, we need s values, right? We need the summation of all the s values, but even before that, the n here represent the number of years, or the number of years here. So you can see that we have 1 2 3 4 5, right? So n here is basically n equal to 5. Now what are the s values? The s value is just the summation of all the years. So 1991 plus 1994 year plus 1996, then also 1999, then plus 2005. Now when we sum them up, we are just going to get 9985 here as that. And then also we also need the summation of all the s values, but this time it is square, the square of all the s values, right? So we are going to square each of the years and then sum them up. So we have 1994 year, we square it, plus 1996 year, we square it, 1999 year, we square them up, and then also we have 2005 here, we square it, right? When we square all of these, then the value we are going to get is so we have 199401559. So that will be the value we get for the x squared. Now what about, so we also need the y, and then also we need x and y, the product of them. So we also need the y values here. So the y values here is just 9.85, plus we are summing them all up, so we have 9.79 here, right? Then also we have plus 9.77, then plus 9.69, and this would give us 48.94, right? Okay, now from here we also need the summation of all the y and that of the x, so that we are multiplying them, right? So it's going to be in this way. So let's do it here. So we have these values as we have 1991 here, right, multiplied by 9.85, then 1994 here multiplied by 9.84, then plus 1996 here multiplied by 9.79, then we have 1999 here multiplied by 9.77, and also we have 2005 here multiplied by 1969 here. Now when we compute this, then we should get we should get 97731.83 as the value. Now since we have this value, then which means that from the general equation we had over here, now you realize that from the general equation we had over here, we said n multiplied by a, right? So we have n we said is equal to 5, so we have 5a here. Now good, we have the second one, b multiplied by the summation of all the s values, right? Now when we summed all the s value, we had 9,985, so we have 9,985, then b, then it is equal to the y values we add over here. So y we add 48.94. Then also over here, the second equation, we have a multiplied by the summation of all the s, so it's just 9985 here, a, and we have b multiplied by the summation of all the s squared, so all the s squared, we add this, so we are just going to have 1994159, b being equal to the x and the y, which is just this value here. So we have 97731.83. so we can call this equation 1 and call this equation 2. So what we have simultaneous equation here, so we have to solve this equation. Now when we solve this, we have a to be equal to, so a here will be equal to 33.4367, and b here would be equal to 0.0118, and then since y equal to a plus b, then therefore we can have y here being equal to the a, which is 33.4367 a here, minus that of is minus, so minus 0.0118 b, and that will be for the equation for the baseline, right? Now the question says, what would be your what would you estimate was the fastest time in 1968? So in 1968 here represent the year, so x is equal to that. So for a, if x here is equal to 1968, then which means that what we would estimate for the fastest time would be y here equal to 33.43 here, 7 here. Now it's x here, sorry, x, so it is a plus bx, so we have a here minus b and the x, so we have minus 0.0118 here multiplied by the 1968, so we have 1968 here. So y here will just be equal to, we're just going to have 10.2143, and that will be the estimate for a. Now b also will have an estimate if we are taking the s to be 2017, right? If s is equal to 2017, then we have 33.4375 here minus 0.0118, then 217 here, then y will be equal to, so for this we are just going to have 9.6361, and that will be for a and b. Thank you very much for joining me in this session. I hope this session was helpful, and I'll see you in another section.